Now that we've gone over reducing rationals or fractions, we're going to take a look at what we do when we multiply or divide them. And for the most part, they're going to work exactly like we would expect fractions to work. So I have a multiplication problem set up right here. And what we're going to do in order to reduce this is actually cross-reduce. Now, for questions like this, where we have basically one term in numerator and denominator, I think it's easier ultimately to go ahead and cancel the numbers first, multiply top then bottom, and then reduce at the end. But that's not a method that we'll use for all of them. So as I look across, I see that we can go ahead and cancel the 3 and the 18 by dividing both of those by 3. And we can cancel the 8 and the 12 by dividing both of those by 4. And now we'll multiply top times top and bottom times bottom. So that's going to give me 3a. Now look, a to the 1 times a to the 1 is a squared. C to the 3 times c to the 1 is c to the 4. Now I'm left a little space here because we do have a b squared. So I'll copy that down, b squared. And I have an f cubed. And then on the bottom, 2 times 6 is 12. And I'm just noticing now I could have canceled the 3 and 6. We'll deal with that in a minute. A squared times a to the 1 is a cubed. B times b cubed is b to the 4. So I'm adding the exponents. Rules of exponents are coming into play. C times c squared, so c3. And then f to the 4 times f is going to be f to the 5. Now, just like with rules with exponents, well, first of all, I'll go ahead and cancel those. Divide those by 3. I could have done that up there and divide them by 3, but I can just do it right here. It doesn't matter. So if you catch it later, no problem. So our rules of exponents, remember, if we're dividing, say I had this, which is the same as this, our rule is to subtract. So we get 5 minus 2. Okay, so 2 minus 3, so looking at the a's, is a to the negative 1, which means that the a needs to be at the bottom. 2 minus 4 is negative 2, so there would be 2 b's at the bottom. And 4 minus 3 is 1, so c at the top. And 3 minus 5 is negative 2, which means f squared on bottom. Now, another way to think of that, I'll just look at the f's. I'd have 3 f's on the top and 5 f's on the bottom. And we could cancel those, and notice I'm left with 2 f's on the bottom. So there's another way to think about it. So that's the first solution. All right, so remember when we went over how to deal with dividing, a shortcut that we talked about is keep the first fraction, flip the second fraction. It is very tempting to write at this stage to go ahead and start canceling, but I can't. We can only cancel through multiplication. So I need to first keep the first fraction and then flip the second fraction. So I'll flip this one. And let's see, b cubed, c. Okay, now let's start canceling. So I can cancel 64 with the 12, divide those both by 4. I can cancel 35 and 70. 70 is divisible by 35. So 2 right there and 1. And it doesn't look like I can do anything else this time for sure. So now top times top is going to give me 32. Hope you can see that. A squared times a cubed. B to the 5th times b to the 1, b to the 6th. Then I have cf squared all over. B squared times b cubed is going to give me b to the 5th I note that I also have this a to the fourth here, so I'll copy that down, a to the fourth. 1 times 3, 3. And let's see, c cubed times c is c to the fourth. Now, I'm going to go ahead and cancel what I can. 3 minus 4, negative 1, so that will give me a 1a on bottom. 6 minus 5 is 1, positive 1, so b on top. C to the 1, see that exponent, if an exponent is not written, it is a 1. So 1 minus 4 is negative 3, so that means 3 c's on bottom. And then we have, it looks like I missed an f, didn't I? F to the fourth, so I should have an f to the fourth right there. So 2 minus 4 is negative 2, so 2 f's on the bottom. So always check over your work. Hopefully you find that fairly simple, and that's about as simple as those will get. Now for all the rest of them. So we can only cancel through multiplication, and we can never, ever, ever cancel through an addition and subtraction. So I can't do this, okay? I can't cancel those, not like that. So I need to factor first, and that's generally when we talked about reducing last time. We are going to factor, then we're going to multiply or divide, and then we're going to cancel. So factor that numerator is going to be like this. Now, first step of factoring, we check each thing and make sure that there's not something that we could factor out first. Now, I'm going to throw this x minus 8 into a group just so I remember that's all together. I'm going to treat it like a group. Okay, so in each of these cases, in order to get an x squared, I'm going to need an x in the front. So now I think factors of 16. Okay, since this is a minus, I think difference. So the factors of 16 whose difference is 6, and that's going to be 8 and 2. But this is a negative 6, so I know that that's going to be negative and that's going to be positive. So if this is a negative right here, I know I'm going to have opposite signs. And if it's a positive, they're either both positive or both negative. All right, so 64. Factors of 64 whose difference, or sum, actually, is 16. That's going to be easy. 8 plus 8 is 16. Now, this is a positive, so these have to be the same sign. But they're going to be negatives because this is a negative 16 right here. Negative 8 minus 8 is negative 16. And then factors of 6 whose sum is 5 is 2 and 3. Okay, now we're ready to go on. So now I've switched all of this into a bunch of multiplication. See, everything is being multiplied together. Now I can cancel. Those will cancel. These will cancel. These will cancel. Now, in the numerator is not a 0. Each time I cancel these, I actually get 1s. I'm just shorthanding and not actually writing them. So in the numerator, I have 1. And at the denominator, I have x plus 3. Now, at the last step here, we're going to think, is there anything that x can't be? So remember, the denominator cannot equal 0. The numerator can equal 0, but not the denominator, because then we'd get infinity. So I'd say like x plus 3 cannot equal 0, which means x cannot be negative 3. And that's our final answer right there. And we don't necessarily need to show this part, just that x can't be negative 3. Okay, so remember our trick for division. Keep, flip, change. Now I'm going to do a shortcut here, and I'm going to factor at the same time as I flip. So this factoring will end up on bottom, and this factoring will end up on top. So you'll see that that's why I actually have y's instead of x's, so that we can actually see what's going on. So let's factor this first fraction. I'm going to have x minus 4 and x plus 4. And notice I could factor out a 12. 36 is divisible by 12. So I'm going to factor that out. And that's another way of saying I divide each of those terms by 12. Okay, times, because I'm going to keep the first fraction, flip the second fraction. Now I'm going to factor this denominator, but I'm going to put the answer up here. So I should have a bunch of y's in the numerator. So negative 6 and positive 3 will do it. And then this one I'll factor, but that's going to end up in the denominator because I flipped that second fraction. So minus 8 and minus 4 will do it. Hopefully you remember how to factor, otherwise this will be incredibly impossible. X or the y plus 3's cancel, and the x minus 4's cancel. Don't assume that something has to cancel. You know, you're not guaranteed to have a situation where things actually cancel. So we're going to be left with x plus 4, y minus 6, and we don't need to multiply those out. We'll just leave it. We can leave it in factored form. 12 on bottom, and x minus 8. And what can't x be? Well, this cannot be 8, okay? Otherwise, we get a 0 in our denominator. Okay. So, same idea yet again. Just a bunch of these to show a bunch of different things that you need to remember as far as factoring. So, up here, I can factor out a 4, because 8 and 20, all of those are divisible by 4. So I'll get 2x minus 5. That may or may not help me. I don't know. I have to factor in order to find out. Now, factors of 35, whose difference is 2. Now I should be thinking of 7 and negative 5 times. Now, this one I'm going to have to do in steps. So I'll do the steps like over here. I can factor out a 4. Okay. But now this also factors, so it's very important to factor completely. I can factor that x squared minus 4 to x minus 2 and x plus 2. All right, so I'm ready. Make sure you get it all the way. X minus 2, x plus 2. All right, up here, we're going to have x minus 5 and x minus 2. Okay, now we're ready to cross cancel. So this 2x minus 5 doesn't cross cancel with anything, but the x minus 5's cancel, and x minus 2's will cancel, and the 4's will cancel. We can cancel numbers as well. So in the numerator, I'm going to have 2x minus 5, and nothing else, so I don't need that. Forget that. And then x plus 7. And x plus 2. And let's think, what can't x equal? Well, x can't be negative 7, and x can't be negative 2. Otherwise, that is our answer. All right, this one. So I'm just going to start factoring, but remember we're going to flip these around right here because this is a division. So we're going to keep, flip, and change. So we're going to have x minus 5, x minus 4. How did I know they're negative? Well, negative 9, negative 5 minus 4 is negative 9, and negative 5 times negative 4 is positive 20. Okay, and x plus 7, x plus 3. Okay, we're multiplying. Factor out a 6. And at the bottom, x minus 4, x plus 3. Okay, now we're ready to start canceling. Cancel. Be very tempting to cancel those. You can't cancel sideways, but I can cancel the x minus 4. So what does that leave us with? X minus 5. We have a 6 right here. We'll just copy that in front. X plus 3 and x plus 3. Now, these are identical. So we could write that, although we do not have to, but we could write it as x plus 3 squared because we have 2 of them. Just like x times x is x squared, x plus 3 times x plus 3 is x plus 3 squared. And x cannot equal negative 3. And we don't need to state that one twice, even though we do have that factored 2 times. Okay, let's go on. I do have a bunch of examples of these, but we are getting towards the end right here. So 3 more, essentially. Now notice this one, a fraction of fraction. So when we started this, we talked about complex fractions. This is a complex fraction, and ultimately what they come down to is that this means to divide. But what we need to be sure of is that we have one whole fraction and one whole fraction here. So if we had 2 things that we had to add or subtract, we need to do that addition and subtraction first. And then we go ahead and do the division. So we're going to keep the first fraction, a cubed b squared, all over x y to the 4th. And we're going to divide by a squared b x squared y. Now keep and flip. So we keep this fraction the way it is, change to multiplication, flip this one around. Top times top, bottom times bottom, and that is going to give me, I'll write it right here just because I have the room, a cubed, b squared, x squared, y. I'm going to put them in numerical order. Alphabetical order. Okay, and now I'll subtract exponents. I do think I'm just going to say, you could cross cancel right here. And 3a's subtract 2a's, like that. You could do that. I think that gets rather messy. So that's actually why I don't do it that way. I think it's very prone to mistakes that would be silly. So we're going to go on. Now I subtract the exponents. So 3 minus 2 is 1, positive 1, so it ends up in the numerator. 2 minus 1 is 1. 2 minus 1 is 1. This is a 1 right here. 1 minus 4 is negative 3. All the negative ones end up at the bottom, but we don't write the negative. Now, it is important to note y couldn't be 0 right there. Okay, so getting a little bit more complex in our complex fractions. We'll keep that. And we're going to go ahead and divide. Now, at this step, as I flip, because I'm going to keep flip change, I'm going to factor this. That is factorable, x plus y, x minus y. Because x times x is x squared. And let's go ahead and prove that. X times x is x squared. X times negative y is negative xy. Y times x is xy. Hope you can see that. And y times negative y is y squared. Those two cancel out, and that leaves me with x squared minus y squared. So yes, that does factor right there. Times. Now we're going to flip. Now notice, this is y minus x, and that's really close to these. So we're going to pull a trick, and I'm going to show you what that trick is down here in the corner. If I have y minus x, I like the highest power of x, or the alphabetically first variable, to be positive. In this case, it's not. So I'm actually going to factor out a negative, which means divide these both by a negative. So I divided them both by a negative, and now I'll change their order by the commutative property. And now I see that I'm going to have something that cancels that I wouldn't have normally seen. And I see that the x minus y will cancel with this x minus y. So whenever you have this situation, especially working out of a Algebra 2 textbook, where you have like x's and y's and then like they're close but only different in sign in the middle, like try factoring out that negative and see if you get something that can cancel. Okay, so I'm going to go ahead and cancel this right here just to save some time. So x squared divided x is just x, and that's going to change to 1. The 4 did not cancel. So top times top, we're going to get negative x all over x plus y. Now, there is a restriction here, but it's kind of hard to state. This denominator can't be 0, so I can't just say, so here's how we would state that. X plus y cannot be 0, which means x cannot equal negative y. So x is not equal to negative y. Or negative x can't equal positive y, it doesn't matter. But this sum cannot be 0. All right, last one. I know that was a fast. It's a lot, and it can be rough, especially if you have trouble factoring, so that might be something worth reviewing if it's something you have trouble with. So we keep this first fraction. And yeah, I'll go ahead and do it in steps. We're going to have a multiplication here in a minute. So again, see this minus right here. So we're going to flip, not that fraction, this second fraction. And I'm going to go ahead and factor. So how can I factor this? Well, I need a 9 right here. I know the middle term is 0, so I'm thinking 3x times 3x gives me 9. And I'm thinking negative 2y plus 2y will give me the negative 4y squared, and the middle will cancel out. Times. That's going to end up on the bottom. So I see that right here, those are going to cross cancel, and I'm going to be left with an x in the denominator and a 1 in the numerator right there. Okay, so I'm going to do that trick again. So I have 2y minus 3x, and you see it's so close, right? The y is second. I'm going to factor out a negative, and I'll switch the order, commutative property, and negative 3x minus 2y. All right. What cancels? This, and this x. Because, yep, 3 of them down here, 2 of them right here. All right, so in our final answer, we'll have negative 3, no. We have we do have a negative right here. It'd be very easy to lose that, negative 1. And then in the denominator, x and 3x plus 2y. Now, what are our restrictions? Well, x can't be 0. That's easy. And then this thing can't equal 0 either. So 3x plus 2y, that can't be 0. I'll solve for y. Why not that? Because it doesn't matter. Y cannot equal negative 3x divided by 2. So for whatever that's worth. Those are our restrictions. Okay, that wraps up this section.